Alright y'all, this video is going to cover related rates, okay, how they work and how to recognize them when you see problems. Okay, so first up, this is number 13 on the Unit 2 concept list. It says, a manufacturer has found that the cost C and revenue R in 1 month for a certain product are related by this equation. Determine the rate of change of revenue with respect to time when the cost is changing by $15 per month and the monthly revenue is $25,000. Okay, so a lot of times this respect to time is a key indicator that we have a related rate because that's how we compare our variables that are changing. But the big key part here is that we're relating the rates or the rate of change that is happening. So our two variables, cost and revenue, should both be changing at the same time in relation to that time value. So if you look through your problem and it says the rate of change, or words that mean rate of change twice, once compared to each variable, that's what's going to tell you this process is going to work. So it says the rate of change of revenue, that's our rate for the first one. And then it says that the cost is changing. So this changing is what tells you that one's already also a rate happening. So here's how it works. Once we determine that's a related rate, we're going to look at our formula, and I'm just going to rewrite it so I can manipulate it here outside of the reading. And what we're going to do is, because rates of change are found using the derivative, we are just going to do the derivative of both sides related to their specific variable. So if we look at this side, our variable is C, so the derivative of C is 1. And we have to have our notation here. So this is dc dt, derivative of the cost in relation to time. And on the other side, we do the same thing. Remember, if this division is just a constant, really that is the same as writing this coefficient out front and calling it r squared to the side. So if you like that better, it might be helpful. We're using our power rule, multiplying that 2 over, and then bringing back our 450,000, and then r gets to be to the power of 1. Alright, this part is gone, but we have to have that notation just like on that side. This time it's in relation to the revenue, in relation to time. So now we have to understand what all these pieces mean in here. So I'm going to focus on the rate part, and that's our derivative notation here. This dc dt is the rate for the C variable, which was cost, and this is our rate for the R variable, which was our revenue. Okay, and this R was the revenue itself. And now we're going to go through and plug in some numbers. It says determine the rate of change of revenue, which means this is what we are solving for. And then it says when the cost is changing by 15, so our dc dt is 15, and it says our monthly revenue is 25,000, so we've got this 2 over 450,000, and you can simplify it if you want to before. I'm just going to do it all at the same time with that 25,000. Okay, and then times our dr dt. Okay, you can put this whole thing in your calculator. Okay, but that simplifies to 1 over 9 times dr dt. And then we're just solving for that one more step. If I have a 1/9, I'm going to use the reciprocal and multiply by 9 on both sides to go ahead and cancel that out rather than dividing by a 1/9. I don't like to divide by fractions. And then we have our dr dt is equal to 135, and I'm going to use this to guide me with the label. Okay, the R was revenue, so that's money, and it's respect to time, so we just have to go back to our reading. It was our time in months here. Okay, so we're going to say per month. And that's it for that one. Okay, next up it says a spherical snowball is placed in the sun, and the sun melts the snowball so that its radius decreases by 0.25. If we're talking about the sun melting the snowball, that right there is talking about the volume, because the snowball is made up of snow, so that's the inside. Okay, but it does go ahead and tell you volume later in the problem. But it says its radius decreases 0.25 inches per hour, and we're supposed to find the rate of change of volume with respect to time when the radius is 4 inches. Okay, so we're going back to the same process because on the test all of these are mixed up, so we have to know when a related rate is happening. So as we read through here, it says the radius, that's one of our variables, the radius is changing, so that's a rate. Then it says find the rate of change of the volume, there's our second one. If you see that twice, it's a related rate. We're going to take our equation and do the derivative of each side. Okay, this one they didn't give us the equation, but we already talked about it being volume, and it's a snowball, so it's a sphere. So V equals 4/3 pi r cubed, and don't worry about memorizing those formulas, I will provide them on the test. Okay, so looking through here, when I take the derivative of each side, I should have places to put all those numbers. Okay, so first side would look like 1 dv dt. Okay, derivative of that variable is just 1. And then over here, power rule, the 3 multiplies over, and those 3's cancel, so it's just 4 pi r squared. Please show as much work there as you need to. You don't have to simplify it automatically. But again, using our notation, dr dt, because this one's talking about our radius. Okay, so this was the rate of our volume, and this was the rate of our radius. Okay, so now we're going to go look. This radius was decreasing at a rate of 0.25, so decreasing we need a negative 0.25 on that rate. And then it says the rate of change of volume is what we're solving for when the radius of the snowball is 4 inches. So this goes 4 squared is 16. And then bringing down that 4 pi. And our thing we're solving for in this case is already by itself, so that makes things nice. Okay, you can put the whole thing in your calculator. Pi is irrational, so I like to leave it out. We've got a negative number. In this case, our 4 and our 1/4 cancel out, so it's just the 16. Okay, but calculator friendly, do as much as you need. Using our variables will help us with our labels. This was our volume. Okay, so our volume, when we're talking about our label, surface area is squared, and volume is cubed. Okay, so if you look here, this was inches, so it's inches cubed. And then time in this case, it was per hour, so it's per hour, and that's it.